So we'll give a quick introduction, understand exactly like what is Plumber, how it can benefit you during the event, and then we're gonna dive right into the technical part where Eduardo is gonna run the workshop. So a little bit about us. My name is Ido. I'm based in New York. Eduardo is based in Boston, and both of us were Columbia graduates, so we started just as you. And after the degree, we went to industries. So I went to AWS as a data engineer. Eduardo went to Fidelity as a data scientist. And we saw this need in data science in general that, usually engineers and data scientists work together hand by hand, and there is kind of a bottleneck between the teams. So the data science build the model, do the exploratory analysis, and then once the model is ready, um, they need to refactor all of their work because they work in a Jupyter notebook environment, which is the most convenient way to actually explore data and do all of these kind of experiments. And they have to refactor everything and deploy it into production. So we figured like, hey, this is a real problem. Instead of like running all of the code all over again and taking the perspective of an engineer on a data scientist, which is definitely the wrong approach, we thought like, okay, we'll leverage the data science approach and, keep the most convenient tools for them and understand exactly how to deploy faster and build data pipeline without refactoring from scratch the whole code. Um, so a bit about us, we have an open source product that you can see right here. So this is like a tool. We have around 8,000 monthly unique downloads. We have almost 700 GitHub stars. So I think during the event and after the event, you can start this repository. So you can actually have a quick draw of Plumber, and you'll be able to use it during the event. Now, the main thing that we want to emphasize here is, first of all, collaborations, because in the event you're going to work within teams, and it's easier to collaborate with Plumber because everything has kind of like, engineering best practices. So it's easier to share code. And the second thing is you can get to a machine learning model faster and a data pipeline faster. And that just happened because the code is modular and you can build one section and then reuse it in multiple places. So in a time-bound event where you have only 1 to 3 days, that's gonna use you really well, and you can get to a product or an MVP to demo faster. Um, so I think that's pretty much it for the introduction. Now I'll hand it over to Eduardo to take it away for the technical part. Let me stop sharing.
Great. Awesome. Thanks, Ido. I'm going to share a link. Actually, Ido shared that.
Yeah,
Oops.
everything is in the Plumber channel.
Yeah.
So we can just go to the channel and then let's click on the self-paced workshop. Let me repaste it over
All
here.
right. So then I'm going to share my screen.
Everyone go to this link, start the Git, and then we can start the workshop.
Can everybody see my screen?
I can't.
Okay. I thought something wasn't working, but it sounds like you can.
No, I don't see your screen.
Oh, you don't
Does
see it.
anyone?
Okay. Hold on. Let me stop. Okay. Share. And now let me try again. Okay. Looks like it's loading.
Yeah, still loading.
Okay. Um, yeah, that's what I did. I selected the first monitor and still shows us loading. All right, let me try that. Okay, let's see if this works. I shared Firefox now. Still shows us loading. Um, it, or Ido, do you want to try sharing and then I can just explain
Yeah, let me try
and
that.
you just like follow the like the notebook?
Can you see my screen now?
It's loading.
Yeah. Your stream currently has reduced video audio quality.
Yeah, I saw the same thing.
That's weird. But you saw my screen earlier, right? True.
So maybe try again, and if that doesn't work, maybe we can move to Zoom or something else.
Yeah, that might be.
Yeah, I can. So just try again. I'll generate a Zoom
Yeah.
link in the meantime.
Set up the event. Yeah, I'm sharing again.
Okay, it works. So awesome. Please either just like keep with the like moving your screen depending on what I'm saying, and let's make this work. So thanks everyone for joining today. As Ido mentioned, we are working on Plumber, which is a Python library to help you develop data science pipelines. And just a few things to take into account, like this is a project that is already used in production at several companies. And to give you an idea of how this is useful for other companies, one of them reported that they dropped the development time by 40%. So that's a crazy amount. And that's the whole purpose of why we are building this, because we want to help data scientists, students, to develop pipelines faster. So what you are seeing here, please go to this URL. Ido shared this before. And please show your support with a star on GitHub. That helps us get to more people, bring more people to the project, and they can discover it and they can start playing around with it. Now the next thing is once you open that link, you're gonna see that green button that says Start Workshop. So please click there, and you are going to go to a website called My Binder, which allows us to provide you with a Jupyter Lab instance, so you don't have to install anything, and you can start playing, running the same code that we are going to be running. So it's just going to take a few seconds, and you can see already it's loading. So please go there. We are going to just like start with a simple explanation, so everyone has time to click on the green button and then start Jupyter Lab. So I can start with a simple introduction in the meantime. So one of the reasons why we built this project is because data scientists like this Jupyter Notebooks tool. It's a really popular tool. Many, if not most, data scientists use this. And actually, I think I can say most, because in a recent survey, I think it was like 80% of data scientists use Jupyter. So really, really popular tool. The problem is that when you want to take code that lives in a notebook, and what you are seeing right now, it's a notebook. It's just like a document where you can put some text, some images, some code, get some tables, get some charts. And the problem is that once you have this kind of, you have your code in this kind of way, it's really hard to take things to production. There are many reasons for this, and some of them are technical. Some others are like maybe like business things. Like it's really hard to take models to production in a business setting because there are like many interests involved and people want to make sure that models work. But we are focusing right now on the technical issues because that's what we can solve. I wouldn't say easily, but it's more. I think it's easier to solve these technical issues, and that's what we are working on. So we want to help data scientists move from Jupyter to production faster, because right now what companies do is that they take these notebooks, then they refactor the code, and then they deploy, and that creates all sorts of issues because if you are modifying your code, maybe you're not going to be able to reproduce your results, maybe your model is going to have lower performance, and that sort of problems. So that's the introduction. Hopefully by now everyone's able to get the same screen that we are showing. So you click on the green button and then you wait for a few seconds and you get this notebook in front of you. Okay, so let's start. So the first thing that we are going to do is that we are going to show some of the files that we have. So you can see that the first cell, and if you want to follow this notebook, you just have to click on the cell. For example, this code cell is the one that has ls example, the one that you are seeing right now. And to execute that cell, you just have to press shift and enter. So if we execute that, we are going to see two things. This is where we start working on our pipeline. The first thing is the pipeline YAML file, which is the input file that Plumber uses to specify pipelines. And a pipeline is simply a set of tasks that have certain execution order. For example, a typical pipeline in a machine learning setting or a data science setting is you get some data, you clean that data, you generate some features, and then you train a model, and finally you evaluate that model. So it's simply a pipeline is simply a way of saying we have different tasks, and a task is a function or a script or some notebook, and then the pipeline is like the whole thing where you execute things. So that's the pipeline YAML file that we have there, and we are going to see the content in a few cells below. So just bear that in mind. So pipeline YAML, really important file. And then the second thing is that what we are saying is the scripts folder, which is where we are going to be storing our code. So right now what we are going to, so either showing the pipeline YAML file, this is just a sample. Actually, we are going to build this same pipeline from scratch. I just want you to get an idea of how it looks like. So what we are saying is that we are going to declare inputs and outputs. So for example, right now here, the pipeline YAML file has a source, which is saying scripts/get. That's the file that we want to execute. And then product, that's the outputs that we are going to get from each task. So a simple concept, just source code and product, which is outputs. Okay, so let's go back to the main Jupyter notebook, please. Now let's take a look at the example/scripts that we have. And there we are going to see the files that I mentioned before in the pipeline YAML file. So these are the 4 files that we have. They contain our logic, the business logic, whatever we are doing with the data. We're going to implement that there. And this is a really simple pipeline that only has 4 tasks. So we get some data, we generate some features, and then we train a model. Now, imagine that you work on this already and you are ready to train a model. So all you have to do is to execute Plumber build, which is in the next cell, and it's going to start running. It's going to take a few seconds before you see the output, so let's just give it a few seconds to get the results. And so what this is doing is executing our code from start to end. So you can see that it executed the get task. It's getting some data, then it's generating some features, training a model, and then it's reporting the result. Well, actually, this is not the result. This is just like the time it took for the pipeline to run. And if you go to the output folder, if you go to like example, example, and then output, then those are all the outputs from our pipeline. So once we execute Plumber build, we get all these files. And you can see that we have, so in our pipeline, we have, for example, get.py. And here in the outputs, we have get.ipynb. So essentially what Plumber is doing is taking our Python scripts and execute them as notebooks. The only reason, and the most important reason why we are doing this is because when you are working with data, it's really important and really useful to get some tables. For example, here, let's imagine, and you can run things in the cloud as well. We are running things locally, but Plumber also supports running things on AWS, Kubernetes. So when you are running things in a cluster, in a remote server, it's important and really useful to get these kinds of things. Like you can see this table here, and that can help you understand what's going on with your code and with your data. So when you are manipulating data, it's really important to and really useful to just get some glimpse of how it looks like. And this can be, maybe you are just printing some numbers, maybe you are printing a table, or maybe you are creating a chart. So the fact that your Python script generates this file as an output, it's just like creating rich logs that then you can take a look at. Please, Ido, go back to the main notebook. Thanks. So that's it. That was just like the first example, a glimpse of how you can run pipelines in Bloomberg. Now we are going to build the same pipeline from scratch. So please, everyone, if you haven't done so, please go to the link that Ido sent and click on the green button so you can get this same Jupyter lab, because we right now are going to start running things, and I'm going to be asking you to do a few things on the notebook so you can follow and build your first Plumber pipeline. So first, please click on the green button, start workshop, and let's hope that everyone, if everyone is not seeing the same screen like the notebook, please send a message and we can wait for you. I'll just continue with some simple explanation, and then in the next section we are actually going to start moving things around and modifying files. So at that point, hopefully you'll have this screen. Okay, so I kind of explained this earlier, that we have this pipeline YAML file and we execute tasks. In this case, we are executing scripts, and we have a source and we have a product. Now I'm going to show you something important. One of the most important or fundamental features of Plumber is that the original notebook format, as you can see right now, if you see the name of the current file is index.ipynb, and that format is actually JSON file. And when you are working on GitHub or GitLab or something similar, if you make changes to this ipynb file, it gets a little tricky to understand what's the difference between the previous version and the current version. All because it has code and output and everything in there. So it makes it a little harder to manage the versions and follow software engineering best practices. So one of the things that we do with Plumber is that we allow data scientists and users in general to use Python scripts as notebooks. So please, Ido, can you go to the scripts folder and then right click on any of the files and then open with and then notebook. So what we are seeing right now is that we have a Python script, which is like a regular text, plain text file, and we are opening as a notebook. And the idea is that the underlying file is like a simple Python script, but we can edit that file as a notebook, which allows us to run these cells, get some charts, but we are still having a simple Python script, which allows us to like just do things with GitLab or GitHub. You can see it is running some of the code, and that's really helpful for this. Okay, so let's continue, and yes, please scroll down a little bit. So now you are seeing this sample pipeline YAML file. Please go to Ido. Can you click on the root folder? So the folder icon that you see, yes, that one, and then go to playground. Yes. Okay. So please, everyone, go to. So do the same thing that Ido did. So click on the root folder and then go to playground, and then you have to create a new file there. So right click and then new file, and then it's going to ask you for a name, and then just put pipeline YAML. It has to be pipeline YAML, otherwise Plumber is not going to recognize it as a valid pipeline. So pipeline YAML, and then copy the contents of the snippet that you see there. Yeah, exactly. And put it inside the pipeline YAML file that you just created. So what we are doing right now is just repeating the process that I explained before. We have source, which is the Python script that we want to execute, and then product. And we have 4 of them. Right now, we only specify the structure. We actually don't have any of those files because we started with an empty document. So please, Ido, go back to the main notebook. And now we are going to start building the pipeline from scratch. So if you go to step number 1, so please, scroll down. And what we are going to execute right now is a Plumber scaffold, which is a command that allows us to create some sample files based on the specification that we just did. So please run it. Everyone, please run this cell, and then you're going to see this output, which is telling you that Plumber created these files that you specified in your pipeline YAML file. Now, these are just basic files. They don't contain any logic, so we have to work on adding a bit of code so that we actually do something in the pipeline. But let's run Plumber status, and to make sure that Plumber recognizes these 4 files and the pipeline YAML file as a pipeline. And you can see that here. You can see the summary. You can see that we are getting a table with a few rows, and each row represents one task in our pipeline. So that means things are working. Please scroll down, and I think we are going to create a plot. Please execute that one. So right now we are executing Plumber plot, and this generates a pipeline.png file. And you can see that Plumber recognizes this pipeline, and we just have these four elements or nodes in this graph, and each one represents one task in our pipeline. Now, this doesn't have any order. This looks a little bit strange because we don't have any order, and we should have some order. We should get some data, then generate some features, then train a model. So that's what we are going to be doing now. We are going to be adding some structure to our pipeline. So what we are going to do is step number 2, please go to Playground, Scripts, and Features Petal. So to give some background on which dataset we are using, and then once you have Features Petal, please right-click. Yes, open with, and then Notebook. Okay, so just to give some background on which dataset we are using a sample dataset that many machine learning samples use. And this is just data on flowers, and we want to predict based on some measurements from the flowers. We want to predict which type of flower it is. So we have these two different measures. Well, I think we have like 4 of them. So the first thing that we are going to do is we are going to create a new column based on columns that we already have. So this is called a feature. A feature is simply one computation that we do, one new column that we create in our table, tabular data, that's going to help us make good predictions. So please either go back to the index.ipynb, and then we have scroll down. So the first thing that we have to do before even we specify the logic that we are going to apply, we have to modify this upstream variable. So that's a special variable in our notebook. So if you go back to feature petal, you're going to see that it currently says none, which means that no task should execute before this one. But that actually is not what we want, because if we are going to generate some feature, we actually want to execute the get.py file first, because that's the one that's going to return the data. It's going to download that from a server, and then we want to use that as an input for these other tasks. So that's why we have to modify this special variable and put it as like upstream equals and then a list, because it may have a task may have more than one dependency, more than one task that we want to run it before. So in this case, it's a list of a single element, and the only element there is get. That means execute get.py first before you execute feature-petal. Please save that, yes, and then let's go back to the index.ipynb. And now we are going to repeat the same process for the other 3 files. And the reason why we are not modifying get.py is because that's the first task in our pipeline. So there we cannot run anything before. That's the first task. But then we are going to, if you go to step number 3, scroll up a little bit. Yes, features petal. And then we are going to make the same change. So we are going to open features petal as a notebook. The second one, oh yeah, the second one, because you already modified the first one. So open with and then notebook. Yeah, great. And now we are going to make the same change because we also want to execute get.py first. So upstream equals a list of a single element, get. Yes, and then we save that. And then we go to the last file, which is fit. That should be step number 6. Yes. So now here we are going to make a different change because fit is the last task in our pipeline, and it actually depends on all the previous tasks because we want to get everything that we have done before, and we want to join everything into a single data frame. A data frame is just a representation of our data, or tabular, it's just a table with numbers. So if you go to fit.py, please make upstream equal to all the other files. So just copy paste like Ido did, and you should have a list with 3 elements: get, feature sepal, and feature petal. Now save that file. Yep. Now let's go back to the notebook, and now we are going to execute Plumber plot again. So remember, we already executed Plumber plot, but before that happened, before we declared the dependency. So now what we are going to see, which is what you're seeing right now in Ido's screen, is that we specified some order of execution, and we can clearly see that we are getting some data, then we are generating some features, and finally we train a model. So we have the basic structure of our pipeline. And then if you scroll down a little bit, you are going to see the reference diagram. So your diagram should match the one that you have in that notebook. So what we've done so far is just create some sample files and declare the structure of our pipeline. Now what we have to do is to actually code the logic, right? So the things that we want to do to the data. So now we are going to be copy pasting this code. So step number 7 is we are going to copy this small snippet into get.py. And can you open it as a notebook? That's yeah. So since this is a Python file, we can open it as a script or as a notebook. And it's more convenient to open it as a notebook because we can run things interactively, and that's the whole purpose of using Plumber, that you can use Python scripts as notebooks. Now what we have right now is just like a bunch of I think it's like 10 lines of code, less than that, and we are just getting our sample data. So we are just downloading the data from, we're using scikit-learn, which is library to do machine learning. We are loading the iris dataset, which I explained before, it's just a sample dataset that we have. Then we save that to a file. And look what's going on here. In our pipeline YAML file, we declare the product, which I explained is the output from this script. So the second cell that you are seeing, the one that says this cell was injected automatically, we didn't write that code. Actually, when we open that file, Plumber is taking the information from the pipeline YAML file and saying, you told me in the pipeline YAML file that the get.py script generates 2 outputs. So here's the path where you are supposed to save that output so that I can then communicate with the other tasks, because they are going to use that file as an input. So we have 2 files because the first one, remember, NB, that's just the output notebook. So we are going to take our script, turn it into a notebook, and then execute it. So we have any charts and any other things that we want. And then the second one is the data. So CSV file, we get some data and we save it into the our environment. And if you see the last line in the last cell, you are going to see that we are using actually the product. That's a dictionary and the product data. And we save that in the place where we are supposed to do that based on information in the pipeline YAML file. Okay, so that's it for the get.py. Now let's go to the next step, which is feature sepal. So please copy that into feature sepal. And what we are doing here is just like a really simple thing. We are loading the data that we got from the previous task, which is get.py. So you can see that the first line. So we have import pandas, which is the library that we use to modify the data. So the second line is saying pd.read CSV, and that means load in the get.py file. Now we are simply creating a new column. This is like a really simple example. In reality, if you are building like an actual machine learning model, this code would be like maybe hundreds of lines, because we may want to do some more complex transformations to create a new column and a new feature that allows us to make good predictions. In this case, simply a multiplication of 2 columns. And that's it just for the example. So please save that file. Now let's go back to the main notebook. And we are at step number 8, I think. No, 9.
9.
9, yes, yes. So same thing, we are going to edit feature petal, sorry. It's the same, the code is actually pretty similar. We are just using a different set of columns from the get.py output and then creating a new column. So that's it. And this script simply loads the raw data and then it creates a new column. Really simple. Pretty much the same thing that we did with the other task. So please save it. Yes. Let's go back to, yes, and now step number 10. Now, this is where things get more interesting because here we are going to train our machine learning model. I can explain quickly what we are doing here. We are loading. Can you copy that into the feed.py, please, Ido? And then I can explain what's going on here. So please copy that and then please paste that in the last cell. Okay, so what's going on right now is that we are importing a bunch of libraries that we want to use. That's the import statements and the from import statements. And then you see this pd.read.csv. We are loading the raw data. Then we are loading the features that we generated from the 2 other tasks. And then we are joining everything into a single data frame because we need everything to train our model. Then we are splitting our data frame in 2 parts. The first thing is the X, which is the features or the inputs that we want to use to train our model. And then Y is the variable that we want to predict. So that's essentially how, it's not the only way of doing machine learning, but I would say it's the most popular one. You have some input features, some input columns, and then using those columns, you want to predict another variable. In this case, the X has measurements of these flowers, and then Y contains the actual species. So I think we have 3 species in this data set. So based on the measurements, we want to predict what kind of flower we have. So next thing that, mhm. Yeah, yeah, no worries, it's fine. We are actually almost done, so it's probably just like 10 minutes. Okay, great. So next thing is that we are going to split our data set in training and test because we want to use a part of the data set for training and then use the other part for evaluating our model. And this is really important, really standard practice when we do machine learning. Then we train a model and we are using this decision tree classifier, which is a model that finds rules for predicting what we want to predict. So we just simply create the classifier and then fit. And once we fit, we can use that model to make predictions. We first save that model into a file because we may want to use it later to generate more predictions. And then we create, we call predict to generate some predictions, and we finally evaluate the predictions using the confusion matrix. And that's it. Can you save that file? I think you already saved that. Yeah, okay. And then let's go back to the index.ipynb. Great. So now at this point, you should be able to run Plumber build. And what you have right now is your finished pipeline. So we started this from scratch. Now we are running everything. And let's just give it a few seconds. Okay, great. So it's working. It means that we built this pipeline from scratch. Everything's working fine. Now, if we execute the next cell, we are going to see the output. So we have everything and it's working. So now the final task in our workshop is to look at one of the most important features in Plumber, which are incremental builds. When you are doing machine learning, you usually make small changes to your pipeline. For example, maybe you are changing the configuration of your model, or maybe you are generating more features, and that usually only affects a part of your pipeline. Remember that your pipeline, in this case, has 4 tasks. So let's say that we want to create a new table. In the feed.py file, we want to print a table with some metrics. That's the code in step number 11 that you see. So please either open feed.py. And now that we open that, we are going to modify that. So we are going to create a new cell and then paste the code below. Yes. Great. So now save that file and let's go back to the root notebook. And now we are going to execute Plumber build. And we are going to see something. We're going to see that Plumber isn't executing everything. It's only executing feed.py. You can see that in the table that prints. It's only executing feed.py because that's the only thing that we changed. And this allows you to make quick iterations. That's really important when you are working with data and you are creating models and all those things. So that's it. That's it for the workshop. Just a few last things that we want to say. This was just running things locally, but you can do many, many other things with Plumber. This is just like a really basic pipeline. You can create more complex pipelines. You can run things in the cloud. And we have a list of resources here. So please show your support with the start on GitHub. And then you have right here the links to the documentation, the code examples, some of the talks that we have given at conferences. And the contact section has, if you want to ask us anything, any questions, you can reach out to us in many different forms. And that's it. Ido, you want to say something to finish the workshop?
Yes. Let me go to the main Discord. So we're happy that you all here. We would be able to support you during the event. We'll be in the Slack and we'll be also in the Discord channel. And we hope you enjoyed and learned a lot. And if you have any questions, comments, concerns, be available at your disposal. Thank you.
Yes, thanks a lot. Thanks a lot for joining.
Thank you.
Great.
That's great.
Thanks.
And we hope it was helpful.